So here we have the same functions as in the previous examples, but we're going to look at the operation of composition. And again, composition simply means to substitute. So when I come down here and look at this first problem and it asks me to do f of g of 2, what I'm really looking at, again, if you go back and look at the understanding of the order of operations, the order of operations starts with the grouping symbol. And the grouping symbol says that it also includes substitution. So we actually are going to be doing the grouping symbol twice, is what this means. So I look at our example, it says first, inside, I want to group this part. So I'm going to first find g of 2. I'm going to do this part first because it is inside the grouping symbol of f. So I'm going to do 3 times a parentheses, and in the parentheses will become 2. Again, the parentheses is the replacement for x, and that is just 6. And again, we're still just doing Gelndos. So what I'm going to do now is I'm going to drop down the operations I have not done, which is f and f's parentheses, because the parentheses around f have not been completed either. And so now I will do f with 6 inside. So I'm going to write down 12, a parentheses to replace the x value, and then a 6. And now I just go through Gelndos again, starting with, in this case, multiplication. 12 times 6 is, of course, 72. And 72 minus 9 comes out to 63. So what you see has happened here is I basically have substituted 2 in to the first function. And then once I have done that, I have then taken that output, which was 6, and substituted into the next function. So let's take a look at the next example, which is the same idea with a different notation. So this is h of 1. Some students prefer it written like this, where you say h of 1, which would put it more in line with number 1. And in fact, if we want to go back and look at number 1 could have been written like this. It could have been written as f of g of 2. That is the same problem that we did. And so this problem, if you don't like this notation, just ignore that notation and use this notation, or use the other, whichever one makes the most sense to you. So again, we're substituting 1 into the x's for this function, which is h. So h without its x's looks like this. And then we're going to plug in the 1. And that is, again, that's all composition is. Composition means substitute. Then we obey Gelndos. We're going to do the exponent first. 1 squared is 1. Then multiplication. 5 times 1 is 5. 1 minus 5 is negative 4. So once I have that answer, I am then going to take that answer and drop down these. I drop down the h, right? I drop down the parentheses. And now I do the same problem again using the same function. So it's just substituting 2 times. So I get rid of those x's. I use parentheses. I'm now going to plug the negative 4 in, because negative 1 was made by, negative 4 is made by 1. 1 made negative 4. Negative 4 now goes in. So negative 4 squared is 16. Negative 5 times negative 4 is positive 20. So that will give me 36. So again, it's important to do math in a column. Most math teachers like to see your answer down at the bottom. You don't have to underline or anything. They understand that that is the result. So now let's take a look at what happens when we try to do composition or substitution without a input value. So when I take a look at f of g of x, it's asking me to take g of x and put it into f of x, exactly like we did here, but the difference is there's no number to reduce. So g of x is in fact just 3x. It's basically telling me to plug x into g, but x is already in g. So that's done. There's nothing to do there. That operation is completed. Then I'm going to drop down the f, okay, and technically that parentheses is part of the f. And now I'm going to find f with 3 of x plugged in. So f of x is again 12 parentheses minus 9. And the difference is, in the first problem, g of x yielded the value of 6 when I plugged 2 in, so I plugged 6 into f of x. But here, it didn't evaluate, so I just plug in 3x, and then I complete the operation. Here I multiply 12 and 6. Here I multiply 12 times 3x. So that's going to give me as my answer 36x. The 9, of course, does not have any operation, so it drops down. So the function made by substituting f into g is 36x minus 9. So here I did that other notation of h of f. It's not half, it's h of f. If you don't like this notation, this can be written as h of f of x, like this. And again, if you like the circle-y open circle notation, this could have been written as f of g. They are the same thing, f of g. This problem and this problem are the same. This problem and this problem are the same, whichever one you prefer. So let's take a look at what that looks like. H, again, is this function right here, x squared minus 5x. So it's going to have a square on it with a parentheses instead of the x, and then a 5 in a parentheses. And then inside of the parentheses, I'm going to plug in 12x minus 9, which is f. And this is done. That is the composition of the two functions. The problem is it's not simplified. So now we have to obey Gelndas to simplify the problem. And one of the most common errors that is seen in higher level math classes is people trying to distribute squares. And you'll remember what I said. I don't like to distribute anything. I like to use the box or area method. A square does not mean distribute. A square means to write something down twice. So that square actually means to do this. And so trying to distribute those in there like that, it basically what it does is you're starting the problem out with an error in operation. So once I do that, I like to put the first one in a column and the second one in a row. So the second one, which is the same function in this case, I put in a row. And then I draw an area model around that to keep all of my answers organized. Okay, so same process we saw in the previous examples. 12 times 12 is 144. I have the same base here of x. So I write that same base down, and then I add the exponents. 1 plus 1 is 2, or square. Here I have negative 9 times 12, which is negative 108. And then the x just drops down since there's no x on the 9. Luckily, when you do square things, there are duplicates. So 12x times negative 9 is again negative 108 with the x. Okay, and then the last thing we have is negative 9 times negative 9, which is positive 81. And it does help to just put that positive in there because you're going to need it in the answer anyway. Again, as mentioned before, the like terms, if both of them are put in standard form, are on the diagonal. So 12x minus 9 squared is 144x squared. My like terms are negative 108 and negative 108, which is negative 216x. And then plus 81. And a lot of students, they'll accidentally think this is the answer, but we never did this part. So now we are going to multiply this together. If you want to use that box method, it would be negative 5, and then 12x minus 9 would go along the top. Again, I try to avoid distributing just because of the fact that kids will distribute at the wrong time, producing an answer that they got wrong and they don't know why. So doing this, we never have that problem. So this is negative 60x. This is negative 5 times negative 9, which is positive 45. Those will now drop down, just like this drop down. This will now drop down here, and then I will combine my like terms. And so what I want you to notice is that this problem was difficult, not because of the substitution. The substitution has already occurred in the first step. It's the order of operations that we've been learning since Algebra 1, which is making this problem longer. So my like terms, I don't have any extra squares, so I just have 144x squared. I do have a like term with the negative 216 and the negative 60x. So that's going to be negative 276x. And I have a like term here with the 81 and the 45, which adds up to 126. So be careful. Take it one step at a time. Remember that substitution is the top of Gelmdas, so it has to be done first and completed when there is a number. Also notice here there are no domain restrictions because none of these problems, look, there's no division anywhere. So I know that we learned about domain restrictions earlier, but there are no domain restrictions here because we never use division.